All right, great. Okay, let's start. So yes, the question is a friend, and yes, so this is Inkie. So we started I started last year, very late April, close to May. Yeah, so I think as you guys have found out, or I guess at least part of the Discord group, you guys would have seen that we are trying to provide academic help, be it homework helping or creating content videos, which we are kickstarting again. Actually, we have kickstarted already, starting with the PNC videos, and slowly enough, you see some from chemistry. So yeah, so we are basically we are non-profit and we just want to help because of how Singapore's education is. All right, let's just stop there. Okay, moving on to me, the less important one. So yes, I'm a small lizard, and that is me. Of course not. And I graduated 3 years ago. It's quite a long time, in 2019. Yeah, with further math, chem econs, which is a very dinosaur combi. You never hear further math and chem too much, I guess, especially in Hua Chong. But yeah. All right. So yes, further math and chem. That is, I think you can probably guess what my two favorite subjects are. Lah. All right. And yep, I'm as always the author of the skill sets on Inkie's Discord. So if you have any problems with it, you guys can ping me or kill me after you. And I'm also the lizard behind the math content videos, especially the PNC ones, and also the ones that we produced last year, especially the Into Our Minds video. That one, if you're interested, you guys should go and watch that as well, because it covers the same idea as what we are doing today, right? How do I work with questions and the approaches that I'm taking. And yes, I'm waiting to go university, studying math and stats. And yep, that's my IG and my YouTube channel, which is kind of inactive because I'm focusing on Inkie. Yeah, but yes, for YouTube, I'm slowly trying to get back to it for starting with vectors again, or continuing with vectors. So if you are still weak at vectors, you guys can look out for that, or read the skill set notes on vectors, or for some reason, you guys can also watch the YouTube, or rather the webinar that I conducted last year regarding vectors, and it's a whole crash course. So that one can take quite long. That is like 2 hours long. All right, so that one you should segment it. All right. So what is making friends with questions? So why I say that you should make friends with questions is because the idea of friendship, right? It's all about collaboration, understanding each other, and enjoying each other, right? And it's kind of weird, right? It's like, why would I enjoy the company of questions, right? Ultimately, we need the mark. And we really need to work with the questions. And to do that, we need to put in that effort, right? So what can we bring to the table, which is basically what we have or what we know, our knowledge, our techniques, our habits, and our mindset, so that we ourselves can enjoy doing math. All right, give me one. Someone's joining. Okay. So that's why we need to make friends with questions, because they are really trying to help us, right? And to just turn them down or to vilify them is really not fair, right? And it actually does us harm by just being annoyed at them or just being very resistive. All right. So we should really approach them and really embrace them so that we know what they're trying to tell us and how we can work with them. So that is the technique. And that is the idea of wanting to befriend the questions. All right. Is to see them as an ally and not an enemy. Okay. And people ask me what's my view on H2 math. And I would say that, as I mentioned to one of you guys earlier, it's really about puzzle piecing, right? So when you create a puzzle, you can start from here and then you slowly build up. All right. But in H2 math, there's also another way to build a puzzle, or maybe you guys build a puzzle this way, is to start from here, and then you find the missing link. Right. So that is really the idea of H2 math is you try to either build a logic flow from A to B to C, or you try to go from A and you know how it should end. You just that you cannot find a way there yet. So you have to find this missing gap right here, which is actually it's a very important technique. Is when you know you cannot find a way there yet, how about try working backwards and then find a way, or rather cheat a way in, because that is sometimes how we usually need to actually approach it to math. All right, especially right, one example that comes right out of my mind immediately when talk about A and A to prove C is the idea of proving trigonometry identities in secondary school. Because sometimes they ask you to prove that a certain trigo to let's say a singular term trigger, then you like don't know what to do. Then sometimes you know that you can manipulate this. Oh, hey, I just need to times very stupidly, let's say cosine x over cosine x, and then you're done. Right? So this is really the first encounter you have with the idea of puzzle piecing, of finding that missing link between the start and the end. All right. So my advice is try not to think very linearly throughout. Of course, it's good to see the entire path, but sometimes you should see the path from one end and from the other end, the start and the end, and then pushing them together. All right. Now, so that is the logic of H2 math papers. How about you actually doing it? It's actually basically a performance backed by your preparation. Whatever you're doing right now with your questions will be the exact same things you're going to be doing in the exam, albeit with the extra time pressure. And that's why there is this mental and technical aspect that you need to to acclimatize yourself to. One is your expertise, your understanding of your skills, your knowledge. The other aspect is how you're going to cope with that mental stress or lack thereof. And of course, the lack thereof part will be good lah, if you don't feel any stress doing math papers. All right. So this whole webinar will be basically tackling that aspect of the performance, right? How do you grind to get that skill, or maybe not even grind, how to actually get good at that skills whilst also building that mindset and that approach to actually tackle H2 math questions. And that approach is basically making friends, something that is positive, something that is collaborative and wholesome, hopefully. All right. Now, again, some of you guys actually also asked in the Google Forms is, how do I study, be it for exams or for, let's say, certain topics? Okay. And sounds impossible, right? Because if you don't like math, then how am I supposed to enjoy studying math? All right. I want you to enjoy the preparation, not necessarily enjoying the subject as a whole, but enjoy the preparation of finding your own ways of learning. Okay. And the way to do that is not really just by really just keep practicing, because that I feel is, on one hand, it's really very annoying. Like you're doing it as if that is very emotionless, meaningless. And of course, that will be very negative on your psyche. So instead, maybe try to do something else. Like really try to make it fun. Can be a lame way, can be a very stupid way. But as long as you find joy in learning and understanding that logic, that will be fantastic. All right. So that is really how I study most subjects, minus physics. That's why I didn't take physics. But yeah. So that will help you a lot, right? And treat it as a challenge instead of trying to cower away from it. All right. Find a way to think, personalize it, personalize it with your own interests. That can be not related to the math, could be like, I don't know, poker or something. I don't know what you guys do nowadays. Or try to just find a very stupid way to remember it. Like, I don't know. But what I do is like integration by parts. I have like this random jingles that happens in my head. And that helps me to remember it. And that's why it's also a performance, because what am I doing? All the habits, all the quirks that I have during my own practice, I bring it to the exam, right? And it makes it a lot more manageable during the exam. And that's how that's how I do math papers in be it further math or H2 math. All right. So really, the important part is to have fun, right? Discovering stupid lame ways of learning, and then build those habits. All right. Then of course, the important part is don't make sure it's all correct. And if you ever doubt yourself, it's best if you can show yourself that you are wrong. All right. If not, ask someone else, ask your tutors. You can ask the Discord tutors as well, ask your school tutors as well. And pretty sure they will understand where you're coming from. All right, and they'll be able to correct you immediately. Okay, that is on how to study. All right, in a more actual advice, more concrete advice, whatever you do, right, start with keeping your techniques. All right, know what you need to do, know what you can do. If you don't know what you can do, then of course you're going to a battlefield without any arms. It's an instant death. All right, so go in, or rather prepare yourself, get that techniques right, get those fluent, right? Be it finding your own ways to do it, and at the same time appreciating those ideas. Okay, build mindsets and habits, which I'm going to talk about in more detail later. Appreciate the logic and revelations behind it. All right, because sometimes even as good as you are in H2 math, there'll be times where you hit this stupid mental block, and then you realize is, oh, I just need to do this, and then you just get very disappointed in yourself. Happened to me, happened to a lot of you guys as well, I'm pretty sure. So the main thing is always to take it very positively. Right? Appreciate the logic, so that because in H2 math, what many people tend to do is to overcomplicate things, right? Because they think that whatever they're doing is really basic. So they think that, oh, it must be more complicated than that, more complicated than that. And in fact, it's not, right? Sometimes it's really actually the same level of ideas. Or sometimes even is a regression. It's just even more basic than that. And then what catches many people off guard in math, and that's what many people fall as well. Right? It's the inability to realize that, okay, maybe I should look backwards instead of forwards. All right. Sounds anti-life advice because we always talk about moving forward, but we only have the assumption that where we are right now is where we should be. All right. In math, sometimes what your proposed method may not be the correct method because it's already very complicated. All right. And we'll see that later on. And of course, when you're building this mindset, you get that experience, which is very necessary for you to widen your knowledge and also know the different ways to use your expertise, aka your methods, your tools. All right. And of course, eventually, once you're done with the topical exercises, you get good at your techniques, you then move on to papers where you now be tackling all sorts of questions, not just limited to one topic, and then continuously doing them. All right. Now, important thing is this, right? I think if you're an athlete, you will know the routines and techniques. It's all about that self-reminders, that positive reinforcement that you guys should go in with. All right. Go inside there with a heart that is willing to learn, willing to fight. All right. If you go inside there being very fearful, then of course you're not going to make any friends. All right. Go in there ready to have fun, ready to mingle. That's how I tackle almost every paper. Okay, is that confidence that takes time. I know it takes time to build because important thing, it comes from your techniques. All right, with this builds confidence. With that confidence, you then can create those techniques and those routines. All right, then of course, when you review your exercises, your weak points, your topics, your mindsets, whatever that you realize that you're struggling with, let's say, for example, you didn't spot specific information or apply the techniques wrongly, take it positively, right? Because now you learn. It's better to learn from your preparation than to learn in the exam, all right? Because if you learn in the exam, it's too late, right? But of course, sometimes you also learn things in the exam, which is a good thing, okay? So right now, just start with your techniques and then build the mindsets, which what we're gonna do today. Right, but first, since I talk about techniques, let's talk about techniques first. Understanding the ideas and concepts and appreciate it, you must know the purpose or sometimes the derivation of the ideas and techniques. Now, purpose of ideas and techniques, well, sometimes it is very important, right? Let's say for your sigma notation, your manipulation of sigma notation, or let's say for derivatives, we talk about what is the idea of differentiation, what's the idea of the first derivative, and then let's say other techniques such as simplifying improper rational fractions before integrating. So let's say you have fx over gx that you want to integrate, and they are improper, so they are algebraic polynomials. Then you have to divide first because you can use the other identities as well, be it your ln, be it your tangent inverse, be it your, okay, that's about it lah. Yeah. Okay, so of course, that's the idea of purpose on derivation of techniques and ideas. Some ideas you do have to really know the derivation, like your product rule, your quotient rule of your differentiation. That's not needed because that is really coming to university calculus, which I'm gonna do, so that's a bit scary. But yeah, otherwise, really, it's understand the purpose and derivation. Sometimes it's really also boils down to common sense and just basic ideas, all right, which we'll talk about later on. Okay, and appreciate the concept and give us a reason to enjoy it, which will make it a lot easier to remember, all right, and to be fluent at. Okay. Execution technique. So one is about understanding how to do it, all right? But you can understand how to do it and you're very slow during an exam, that will be a big demoralizing factor. All right, so execution of techniques come in two forms: the thought processes, let's say the jingles I have, or spotting the pattern. And I'll give you two examples later on. All right, so building familiarity by choreographing your techniques, right? Let's say, for example, we talk about integration by parts. We know that, let's say you have, for example, integrating x ln x, right? Integration by parts is the clear method here. Now, how do we perform integration by parts? Always remember this: integrate one, differentiate the other. See, that's how I remember it. So I integrate one, I integrate x to become x squared over 2. Then now I differentiate the other, which is to differentiate ln x. And this will just give me x over 2 dx. This will then give me x squared over 2 ln x minus half. Okay? Because this will then give me x squared over 4. And then, of course, not forgetting your favorite constant plus c. All right, so that is how I do it. So integrate one and then differentiate the other. And the idea that this is a minus sign, that one will come with enough experience or enough derivation as well. All right, manipulation of sigma notation comes under opposites graph transformation. So idea is that, let's say for sigma notation, you have n r equals to 1. Let's say, for example, this is f r. Then you want to manipulate it, trying to change the limits. Let's say this one, you add 1 to the limits. Of course, it's the opposite for the function. You add 1 to the limit, you minus 1 from the function. Likewise, if you minus 1 to the limit, so you get n minus 1, then the opposite will happen. You will then increase 1 in the function. All right, so this saves a lot of time during the exam, right? Because you build these habits, you build these techniques. Exam, you just do only. Right? Because it's so subconscious, it is very instinctive. Okay. Now, of course, the rest, half angle trick, all these very niche. Half angle trick for complex numbers, or forming equation of a line. This one, with enough practice, is actually you start to see a pattern. All right. So this is either building techniques so that you can get confident, followed by getting faster. All right. So even simple things like changing base of logarithm, right? Let's say we have log AB, you want to change to base C. Very simple. What remains up remains up. What remains down remains down. So a B is on top, so B will be the top. A is at the bottom, A will be at the bottom. As simple as that. All right, it's really just about pattern recognition. And one very important pattern recognition to save time comes in the form of sigma notation. All right. Now, if you look at, give me a moment. So if you look at sigma notation, all right, so I will leave out the proving of the first one because I think it's quite simple, right? So first one, let's just do it. We have 1 all the way to n, so you know that there are n groups over 2. So n over 2 groups, then multiplied by the first term and the last term, so you have n plus 1. This will then give you 2 over n plus 1. From here, you know that you're going to break it down to partial fractions. And since this is positive, you know that you have 1 over n and then n plus 1. All right, something like this. The 1 over n has to come first because this has a bigger value. All right, then, well, we can work it out. N plus 1 minus n will give you 1. I then need to times 2. All right, so that is how you can very simply do it. All right, so this idea of converting to the summation of a GAP should be very fluent with you. All right, number of terms divided by 2 because you have number of pairs, then just simply taking the first and the last term. Then from here, you know that, okay, you want to find this summation. So we have 1 over 1 plus 2 plus all the way to n, starting from first n is 3, so n equals to 3. Actually, you can't use n because they have n here, so let's change it to r. So this is how I do math, because, yeah. All right, so I do have experimentation. R equals to 3, to 1 plus 2 plus all the way to r. Then you notice from here, it's basically the partial fractions right here. All right, so first you have 2, then you have n, r equals to 3, 1 over n minus 1 over n plus 1. And you clearly know that this must be the method of difference, right? So again, because of the minus sign, therefore you talk about MOD. All right, I'll explain and I'll show you that this may not necessarily be the case 100% of the time. So, but regardless, you know this is MOD. So once you know that, okay, how do you spot pattern, right? So what pattern are we seeing? So you notice that when you do MOD, we have 1/3 minus 1/4 plus 1/4 minus 1/5. All right. You notice that you already wrote 2 rows, you get cancel 1. All right. Then you notice that that means at the end, you just only have 1 row left. All right. So this is the first pattern or first building of ideas you can really notice is, you know that at the end, you just need to have 1/n minus 1/n plus 1, because you just need 1 row left, since the last row is really part of the cancellation. Oops. Then you just cancel. You know that you get 1/3 minus 1/n plus 1 times 2, and that will be your answer. All right. Another way to do it is to realize that when you do MOD, there's this diagonal, what do you call that? Symmetry. All right. If there's one term on top here, there'll be one term at the corner here. All right. And that's how you can really make your MOD even faster. All right. So you notice my MOD is only 3 lines. Yeah. I mean, of course, higher level, you don't even need 3 lines, or you just write down the answer straight away. Okay, so that is the type of pattern recognition I'm talking about, that when I was referring to earlier. All right, the thought processes, the patterns. All right, find these and create this yourself. All right, it'll make things not only fun, but during an exam, it's faster. Okay. Now, just another example. So you notice that for this MOD, you realize that it's 1/2 plus, or rather minus 1/4, and then 1/3, and then 1/5. There's no cancellation yet. So 1/4 minus 1/6. Finally, there's a cancellation. And you notice that you need 2 terms here. So that means at the final time, you need the last 2 lines. 1/n, 1/n plus 1. So this n minus 1. So 1/n plus 2, 1/n plus 3. And again, you notice that it is still symmetrical. There's the first 2 terms right here. There must be the last 2 terms right here as well. All right, so this is how you can do your MOD fast. From here, you know that it's simply 5/6 minus 1/n plus 2 minus 1/n plus 3. There's no need to simplify this. I'm going to combine it into one single fraction, because this is really considered the simplest form. All right, so again, the idea of symmetry in MOD, that's one of the patterns you can see. All right, then soon enough, you see, let's say for graph transformation, it's the idea of opposites. And for, let's say, for complex numbers, the idea of modulus being 1 is rather important. So good. So yeah, this is the kind of a showcase on what I'm talking about, patterns. Of course, if you guys wish to, I can create content videos of every chapter and what the cool techniques that I have if you guys are ever interested, or maybe not so cool techniques. But yeah, I'll leave that to your own imagination, and we continue. Now, sometimes even with the best tools, you must know how to adapt. All right. The techniques may be useful, but it's not universally applied the same way. All right. And sometimes you need to manipulate the expression through like very basic ideas. Squaring and rooting. Let's say you have this weird expression. All right. Then you want to square and then take the root. Could be easier, right, for you to see. So that's what I mean by squaring and rooting. And that comes in many other forms that you may not expect it. So these kinds of fall into the category of experimentation as well. All right, be bold to experiment, even the most stupid things, because sometimes even the most stupid things will help you see things better. All right, because we might be used to looking at things in a very, very complicated way, and that may have instead harmed our ability to understand things. All right. Fourth, H2 math is still math. Means that common sense, basic mathematical knowledge are still being tested, which might be unexpected, as I was talking about earlier. All right, so if, let's say, it's too difficult, you might want to break it down to simple concepts. Or you should link two simple concepts. All right, proving of inequalities of sigma, such as, let's say we have found a summation of 1 over n plus 1, or rather we found a summation of 1 over n, all right? Now they ask you, let's say 1 over n is less than 5, right? No, it's not really 5, right? That's just for example. Summation of 1 over n is less than 5. Now they tell you, what's the limit of 1 over n plus 1? You know that this is less than 1 over n because 1 over n plus 1 is less than 1 over n, right? Because this has a greater denominator. We divide by a greater denominator, our value will be lower. So this is really the simple concepts that they can be testing on, especially for proving of inequalities of sigma, or in anything, really. All right, so you know that this is less than 5. Simple as that. All right, proving equations, especially triangles. We talk about trigonometry, we talk about the identities trigonometry, or we talk about, very simply, similar triangles. All these can come up as well. All right, so go in with your techniques, but also knowing your basics as well. All right, always think of the basics. And what do I mean by experimenting with different techniques? Take a look at this example right here. Not the usual way to do it, but I think that's what they were looking out for. By considering integration by parts, show that the integral of root 4 minus x squared equals to the expression you see right there. The usual way is actually by substitution, but they didn't say that. All right, they want you to do integration by parts. Furthermore, in the H2 syllabus, integration by substitution, the substitution is given. All right, so what do we do? All right, so what you might do immediately, because you see integration by parts, you do it first. All right, try to integrate. So you integrate 1 to give you x root 4 minus x squared, minus away. Now you try to differentiate root 4 minus x squared. So you have x times, first of all, power half becomes negative half. So 4 minus x squared. I bring down half, so I times half, times minus 2x, so I get times minus x. All right, so that's how I can really visualize things. Let me just write it out for reference. So this is the f prime x of your chain rule. So that is basically times x. So times minus x. So you minus will bring outside to become plus, here become x squared. Then you realize that, hey, from here, if I do it again, it's going to be no hope, right? Because now from here, I need to integrate to x cubed over 2. And then I demonstrate again, I get very bad numbers. So from here, you know that something is not right. And then that's not the way to do it. So this is where you know that, hey, integration by parts directly is not the way to go. But we have to do it eventually. So what now? So what you guys might do, or what you guys should do, is something very unique. Something that is not really thought of, but you guys have learned it before. Okay? Can anyone make a guess on how do we actually do this question? You can type it in the chat lah. How do we actually do integration by parts? We know that we cannot do it directly, so there's something we need to do early on. We need to do some manipulation early on. Add 1, like you mean 1 times root 4 minus x squared? Or root 4 minus x squared plus 1 minus 1? What would that do? Okay, let me guess. You're trying to get the form of this, is it? A squared minus fx squared, or a squared plus fx squared. That's your idea? Later, like after the manipulation, or after the integration. After the integration, you get, we had was x squared over 4 minus x squared. You add 1, you notice that you're going to add plus 4 minus x squared. This wouldn't really help, right? Okay, so you realize you're stuck. When you realize you're stuck in the exam, very simple, move on. All right, don't care about this question. If there's future parts, use the result and then solve. Then you come back to solving this later on. All right, but here's the technique. Okay, comes as a surprise. And it's actually a very big clue in why I thought about making friends with the question. You give root 4 minus x squared. Where have you actually seen this in the MF26? It's in the form of 4 minus x squared right here. Right? This gives you sine inverse x over 2. Something like that. Right, I can't remember my formulas, but whatever. Sine inverse x over 2. Right? So is there a way for us to get that? And that we can, right? Because here the clue is that we're going to get back sine inverse. So it means that we have sine inverse x over 2. We need to get this expression right here. And what you might think is, hey, but I got it just now, but it got me nowhere. So is there another way for us to get it? Answer is yes. And it's called rationalizing the numerator. You guys have heard about rationalizing the denominator. Now it's time for us to rationalize the numerator. Bizarre, I know. With this, we can then break it to 4 over 4 minus x squared. And let me just write down the integral. Okay, so this one is a bit of quite mean, admittedly, but yes, rationalize the denominator. Then you know that you're gonna get 4 over 4 minus x squared minus away x squared over root 4 minus x squared dx. From here we get this should be 4 sine inverse x over 2 minus away. Now from here we do integration by parts, right? So how do you want to do integration by parts? You notice that it's not integrating x squared and root 4 minus x squared. Instead, we're going to integrate x over root 4 minus x squared because this is the f prime over fx thing, or f prime over fx power n thing. And then we have x, right? So we're going to integrate this one first because we can integrate that to give us 4 minus x squared, right? Plus 4 minus x squared. Now we have minus root 4 minus x squared dx. Okay, so that's how we're going to integrate that function. All right, so we broke this x squared to times x right here. So we're going to integrate this one first to give us 4 minus x squared. I mean, of course, this is a minus sign, so I already put in the minus sign. Then we get minus 4 minus x squared. All right, so we can make it simpler. We can do it something like this. Okay, then what do you notice? We have root integrate 4 minus x squared, integrate 4 minus x squared. We bring this over. We get 2 integrate 4 minus x squared dx equals to 4 sine inverse x over 2 plus x root 4 minus x squared, and then divide by 2. We get the answer. Of course, plus c. Right, so I think you guys remember this already. Interesting technique. Yeah, all right, so this is one a bit mean example to experiment with techniques, the idea of rationalizing the numerator, because we notice we're going to get sine inverse. That means we want to get root 4 minus x squared in the denominator. We tried to do that with integration by parts, we couldn't, so let's force feed that by putting in the denominator at the very start by multiplying root 4 minus x squared throughout. All right, so that's why the question is your friend, because sometimes the hints that they give are not obvious, but you want to be better friends, so you try to understand them even better and really look up for the clues. Okay, so that is rationalizing the numerator, something that you probably never heard of before. Probably heard a lot of rationalizing the denominator, and yeah, a bit unique. Okay, the prep, the mindsets, and the habits. Now, you need to look for or predict the big picture. For example, in this previous question, we know that we're going to do integration, so our mind should be geared towards integration already. Why must we look for the big picture? The idea is to understand what topics are they testing on, or what topic are they testing on, and what can we use. Now, because with this topic, or knowing what they're testing on, we are able to narrow what we need to, or what we can use, and the available ideas. Let's say for vectors, you're probably gonna narrow your ideas to vectors, length of projection, projection vector, or distance and all that. You're not gonna bring in integration. You're not gonna bring in complex numbers. You're not gonna bring in sequences or series. All right, so that's how you can really gear yourself towards the available ideas and tools. All right, and of course, get ready to adapt. Sometimes you do vectors, you might bring in differentiation because you're looking at minimum or maximum. And the idea of annotation is also very important. Why look for the big picture? So that you know your plan of action. All right. Let's say, for example, the earlier part, we talk about sequences and series, we see a minus sign. We know that we might need to do some MEMOD, method of difference. All right, so that is also the idea of rough plan of action. But of course, if it doesn't work, be adaptive, like what we did just now for the integration question. All right, go into work with the questions, right? When you realize that, hey, there are certain keywords, there are certain keywords, there are certain expressions that, hey, I don't expect it to be there, I will usually underline them and then try to work backwards or work forwards. It really depends on what keywords they give. For example, the integration question, the inverse sign is there. Why will it pop out of nowhere? Which means that we need the root 4 minus x squared in the denominator. Okay? And of course, the importance of annotating, which I'll show you later on. With these keywords, right, sometimes you might take it as face value, and that's all they only provide. Rarely or occasionally, they actually imply another thing. And then asking you is, what can you do with that information? And it's important to visualize so that you know what's going on and you make that mental note. Lastly, how do you work with questions? You get those information, you know what to do. Now it's to draw a link between what you need to do and how you're going to execute it. All right, because you know what to do, you don't have to execute it, then you might as well just don't do it, right? So the idea is to draft a plan. Of course, if you hit a dead end, it's time to go back or experiment, communicate with the question. Talk to yourself, talk to the question. What are you missing out? Or what am I missing out? All right. So because with that, you know what you can do and see if you can do some patching. If you realize you're lacking a certain thing, a certain term, a certain idea, or certain information, then see how can you obtain it. Is it within the question or is it something that you need to do using the current information? All right. So you need to be familiar with your methods, your tools. If it doesn't, all right, like what we did just now, we tried to integrate by parts directly. We see what we are lacking. We are lacking a proper term to actually integrate after that, right? So how can we do it is, okay, we realize we get sine inverse. We need root 4 minus x squared, right? I don't keep experimenting, even more fundamental ideas, right? We went to rationalizing the numerator, which sort of a fundamental idea is just multiplying by root 4 minus x squared throughout, all right? And it could work, all right? That's why it sounds stupid, but it works. Okay, so that is important. All right, when you're stuck, what you might want to do first is to go backwards. All right, think, is there another easier method or basic idea we can apply, and we might be able to roll with it. All right, because we might have complicated things a bit too early, or we complicated things already. All right. For example, this legendary question. You guys can look at it first. I did this question last year, and first time I did it, it took me, you see 2 marks there, right? It took me 8 minutes to solve. When I did this question yesterday, it took me 6 minutes to solve because I forgot how to solve this. And it's the idea of experimenting and taking a step back and not complicating things. Okay? Try to formulate a plan. All right. You guys actually have the worksheet. I sent it through email. Probably not all of you received it because I think there's a bit more people today. But okay, so we have the habits and the mindsets, right? So first part, right circular cone. Right circular cone means the triangle I'm going to get is 90. It's a right angle triangle, the length, the height, and the radius. That's what comes to my mind immediately when it comes to right circular cone. Right? So that is what you need to do when you talk about visualization, talk about information. The cone with the point O at the center, so O is the center. Radius R, slant length L, right? So I called it. Okay, R and L are constant. Points A, B, C, they are on the plane. So what plane? So they basically draw it out for you, which is good. BD is H, AB equals to BC is X. Now, the area S, they given it, thankfully, because I really don't know how to find that area, even without integration whatsoever. So AC, we know that the area is 4/XH, basically this area right here. Show that S is 2LX plus blah, blah, blah. You notice that we went from 4/3x to H being gone, right? So we're going to get rid of H, means we're going to express H in terms of L, R, and possibly X, and likely X. Okay, so what you guys would probably do is, okay, I have triangles. I'm going to gear myself towards triangles. All right, and then you try to whack. And you might get nowhere. Okay, so let's say, for example, you have this H to D here. You try to draw this line down here. Then you realize, hey, it may not be true, right? It may not necessarily be at the origin. So what now? Right, so you might try to whack it out like, okay, can't remember what I did, but yeah, you might just get stuck here lah. All right, try to, let's say, draw a triangle. Let's say you try, you know that D can vary, so you try to put D over here, and then let's say this is D. Then you try to draw a triangle. You get O. This is B, and this is D, and then yeah, you get H. You get you get H. You get the height here, which you are unsure of. Then you get this thing right here. But you can find the height because, you know, this height here from O to D is the same as when you have this height here. So you know that H square equals to root L square, or rather H equals to L square minus R square. You try to put it here. Then you realize this length here is H square minus L square plus R square root. Right? So that is the experimentation you might do, right? You realize that OD is part of OD has a length and it's part of two triangles, and yeah, it can get very weird, right? Then you realize you get nowhere because you get H equals to H. So it's an L right there. Okay. Now, from here, right, actually it's not the end of the world, right? But it's something that you guys might stop. Okay. And in fact, here it's possible to continue as well, but it comes from looking at the expression. All right. First, all right, let's just backtrack a bit. Okay. Right circular cone, we have the idea of the triangle. O is the center, O is the center. R and L, R and L. BD equals to HCM, right? AB equals to BC equals XCM. AB equals to BC equals to XCM. This actually tells us something. Something that not a lot of people might actually catch. Even if you don't catch this, you notice, okay, you know what to do? Look at the expression. Root R square minus X square. Where is R square and X square? Or where is R and X? You notice it's right here. And you notice that R square minus X square, hey, Pythagoras theorem. That means this is a right angle triangle right here. And we're looking at this length right here being R square minus X square. But why is this a right angle triangle? Are we so sure that it's a right angle triangle? Answer is yes. Because AB equals to BC equals to XCM, you can imagine this is your chord. If it is a perpendicular bisector, it passes through the origin. That's why it is a right angle triangle. So that is very sneaky of them, but not so sneaky because you can derive it from the expression. All right, so the question is your friend. It tells you many things that you never expected to tell you. If you don't know, look at the expression. So we have r squared minus x squared over here. Now, we solved r squared minus x squared. R plus r squared minus x squared. What is r plus r squared minus x squared? Look at it graphically, or look at the figure. R is the radius, is over here. But it is also over here, right? This point to this point right here. And this whole length, b to this length here, is r plus root r squared minus x squared. From here, what do we do? Well, you notice that, hey, this length right here is part of this triangle we see. O, B, D, and let's say we name this point E. So we have BDE in this way. You notice that, hey, we are looking at triangles. We look at Pythagoras theorem. What else can we look at? Similar triangles. You notice that this triangle is similar to this big triangle you see right here. All right? So we have this big triangle and then this triangle right here. And you know that this is r plus root r squared minus x squared. Write that properly. You know that this is h. You know that this is L. You know that this whole thing is 2r because radius plus diameter is 2r. Similar triangles, h over L equals to r plus root r squared minus x squared over 2r, h equals to L, r plus root r squared minus x squared over 2r equals to h. You substitute that in, you realize you get this expression. Sounds impossible lah, initially, right? Like, how would I thought of similar triangles? There you go. Okay. Of course, the method just now still works, right? You notice that over here we have, I remember, is it h squared, root h squared minus l squared plus r squared. Then you notice that we can equate them together. We get x squared plus h squared minus l squared plus r squared equals to r squared. Okay, maybe it doesn't really work. Then you get h squared equals to l squared minus x squared. Okay, then yeah, then this one, okay, then you actually get nowhere lah. Okay, so you realize this doesn't work. Okay, fantastic. Yep, good. Okay, I guess it doesn't then. Now I know. I guess that's what I try to do lah. Yeah, okay. Fantastic. Okay, yeah, so good. This is a good example of me just struggling and then finding a way back. Okay, so one way to do it is really using the question to help you, right? Slowly breaking it down. Start from the root, square root, right? You know that you're doing triangles. You have Pythagoras theorem. You have similar triangles. Start with Pythagoras theorem. Then r plus root r squared minus x is this whole length right here. Then you see, hey, maybe I can involve similar triangles because just as I got dh here, and the length I'm looking at is a triangle, I can push this out, I get a similar triangle at the end. Right? So that is what I mean by building techniques, habits, and knowing how to experiment. All right, by making things slightly simpler or by just looking at very similar topics. Okay? This is just the same question without all the annotations. If you guys want to do it again, of course, there's a worksheet that you guys can try as well. So at this point of time, are there any questions before I talk about what to do in the exam and I move on to more examples? May I know why integrating the second part allows us to break it into two parts for the question just now? Oh, you mean the... Oh, okay. Hold on, let me just talk about that. I didn't see that question, sorry. So you mean... Okay, let me just rewrite it again. So over here we had x squared, or rather we look at this part here, minus x squared over root 4 minus x squared, right? So you know that you have to integrate one and differentiate the other, right? If you were to integrate x squared, you know that it's going to be endless, right? You're going to get x cubed, then you're going to get x power 4, you're going to integrate again, and then so on and so forth. So that will be endless. So you know that you cannot integrate x squared, you cannot integrate x. Instead, you have to try to integrate the other way, which is integrate 4 minus x squared. To integrate 4 minus x squared, you notice that you need the f prime, right, which is the x on top. So that's why you need to break it to x over root 4 minus x squared times x. Of course, you need the minus sign here. So we put the minus sign in, we then get the plus outside. Yeah, so I didn't see this part just now, so sorry about that. Yeah, so that was talking about the integration by Keiko. Okay. All right, so hope that clears things up. Okay, let's move on. Okay, so what happens during the exam? You have these habits, you have these techniques, you must go through the mental routine. So what you have been doing in the practices, be it topical practices or be the exam paper, remind that yourself. All right. So it's really for gearing you mentally, gearing for the fight. It's not really a fight, like you're going there for collaboration with the questions. Right. So really positive reinforcement. Remind yourself what you should be doing instead of what not to do. Because if you remind yourself what not to do, then it gets very negative. Then it could affect your performance. Like you get too cautious, then you create that anxiety for yourself, which is not what you really want. Okay. And this is a quote from me. Sounds a bit narcissistic, but yeah. So my philosophy is be good at the easy questions. So you know that questions that are easy, be good at it. But when it comes to the hard ones, be confident. Be confident that you can work with the question. You know how. It's not really you know how to do it, but you know how to work around it and slowly get there. All right. So that's what I mean by being confident. It's not about getting it wholly right. It's about knowing what you can do and how you're going to adapt to it. All right. So be confident in yourself, not in that you're gonna get it right. Okay, so be confident in your ability to adapt. Okay, at least put up a fight lah, or pretend to. All right. Stay composed. Treat every question as a new day. So, in the sense, when it comes to the questions be forward looking, all right, questions at the end they carry more marks, but they are more guided. Vectors, differentiation, all that very guided, all right, which actually increases the chance of getting marks. All right, so don't, it's not gonna be like, last question, like it won't be question 13 or question 11, 13 marks, right? Part 1, 7 marks, part 2, 6 marks. It won't unlikely to happen, I guarantee you, because usually 7-mark questions are at the very front. All right, so very rarely you have part 1, part 2, 7, 6 marks. That one, if there is, probably differential equations, a bit toxic, but it shouldn't be a case. Okay. Although there are possibilities of 6-mark part questions at the very end, but usually there are more parts to it, and they are more guided. All right, so don't worry. All right, be optimistic, be positive. All right, which means continue the routine and give yourself a pep talk. All right, really encourage yourself throughout the paper. It sounds a bit weird. Like you do question 1, okay, good, keep up the momentum. You do question 2, okay, good, keep up the momentum. I mean, yeah, that's how I kind of do it. And now I realize how much of a loser I am. Okay, yeah, so exam, again, do what you've done for the preparation, the techniques, mindsets, and habits. Start right now. All right, whatever I've gone through, the techniques, mindsets, build them already, right? And I hope you guys have been building that for the whole of June holidays. The last 3 weeks, hope you guys have been getting used to the technique, but maybe getting used to techniques on this, but now is also a good time to really explore the techniques, build your own way of learning it and remembering it. All right. Look at the big picture to narrow your number of tools. Experimenting, very important, like the way we did just now for that stupid triangle question. All these very important. All right. So again, tools are meant to be used creatively. So try not to match your tools and then only think that, oh, I can only use this tool for this particular question. Sometimes it's true for, let's say, for a certain topic. Let's say for half angle trick is for complex numbers. Yeah, I mean, that's really it lah. But the idea of factorizing it out, I think that is not unique to complex numbers. All right. So who came up with this quote? Yeah, me, as I was showering. Okay, so it's really important, like try not to close your mind, especially when it comes to approaching math, because it can get really basic. All right, so that is important. Okay, so I know it's close to 2. All right, but from here on is all examples, and I'm going to go through this first example first. All right, so it's a combination of what we have been trying to do. All right, so this question you may think is very basic, and in fact it is. It can come out in the A levels. Right, it came out in last year's A levels, similar to the question now. It can come up in the form of complex numbers, so anything can happen. All right, so fx equals to ax cubed plus bx squared plus cx plus d. How I annotate x plus 1 is a factor. Now, I don't just underline. All right, when it comes to certain things, I don't just underline. What I do is x plus a factor, I only think of equals to 0 because it is a factor of fx. X plus 1 I circle because I remember myself that I need to put in x equals to minus 1. Fx plus show the points A, 1 minus 4, and B, 3 minus 16. Something you might miss out is minimum point. Minimum point, what does that ring? dy dx. Okay, now that's what you can do first. You can annotate and then look at the big picture. But if I want to do the big picture first, that's also possible. You know you have A, B, C, and D. What does that ring? System of equations, simultaneous equations, so SOE. Because I have 4 variables, I need 4 equations. So it means to craft 4 equations, I need 4 pieces of info. Do I have 4 pieces of info? X plus 1 is a factor, that's 1. Fx plus show point A is 2, point B is 3, minimum point is 4. All right. Now, this is a bit dangerous. All right. What I mean by adaptive? Sometimes you have 4 equations, doesn't mean sometimes you have 4 variables, doesn't mean you need 4 equations. Sometimes you just need 3 equations. Why? Sometimes the question is A, B, C in terms of D. So it really depends on the question. All right. So don't go away thinking that, oh, I have 4 variables, I must have 4 equations. Depends on the question. All right, which is find the value of A, B, C, D. That's why we need 4 equations. Okay. So this is how I annotate it. How you want to do it, I'm not going to go through the question in whole, but this is how we talk about very simple annotation, very simple ideas. All right. Work with your pen, working with the question. All right. And of course, catching the idea of minimum point, like just now, the idea of perpendicular bisector. Right. Now, parametric equations. So when I talk about parametric equations, first thing I think of is graphing, if there is differentiation. All right, maybe even functions, quite rare, but yeah. So many different possibilities. Let's see what happens. And it should be very immediate to you that is differentiation because we're looking at tangent. So when looking at tangent, what pops to my mind? dy dx. Point P with parameter theta. So I need to do parametric differentiation. Quite is a given because you're going to find dy dx. Right, so that is that. Tangent at point P meets x-axis and y-axis at L and M. So x-axis, y equals to 0, y-axis, x equals to 0. All right, you may not need to write x equals to y equals to 0. You can just underline it then, or box it out whatsoever to remind yourself. Show that Lm equals to a, the idea of square root sum of squares, right? So idea of a squared plus b squared. All right, if let's say L equals to a comma 0 and m equals to 0 comma b, then we know the length is going to be a squared plus b squared because we're looking at the length of or length between 2 points. All right, so that's how you really want to work with the question. Okay, rate of increase rate of change when looking at d theta dt, because we're looking at rate. Express x over y in a form involving a single trigonometric function. So that means I need to express z equals to x over y, and then find rate of change of x over y, dz, d theta. So this is the big picture I'm talking about. It's really crafting that plan. This question is very linear, right? You go from one end to the other, all right? Then you know what to find already, right? So you need to find dz, d theta, which, or rather dz dt, rate of change of x and y rather. You have d theta dt, so you know what you're missing? Dz d theta. Because you want to connect them. So very simple. You need to find dz d theta, means you need to find z x y first. Then that's it. As simple as that. It's just puzzle piecing. Okay? This one. Why include this example? When I talk about basic techniques, this is what I mean. Prove that ln r plus 1 over r equals to ln r minus ln r plus 1 plus ln r plus 2. All right, I think this one very simple, right? Oh, wow. Okay, I really completely butchered that question. Ln r plus r over r plus 1. No wonder I was... Okay, yeah, so from here it's easy, right? So ln r squared plus 2r over r plus 1. Wow, this saves so much time. Okay, fantastic. Okay, so now this is the wrong question. Okay, yes, but we proved it. Okay, so from here, right, you know that we're going to do a summation of r plus r over r plus 1. R equals to, so we start off with 2, and then r equals to n minus 1, because we have n minus 1 over here. Okay, again, I think I typed it wrongly again. It should be n minus 1, yeah, of course. N minus 1 plus n minus 1 over n. Yes, okay. I will update the worksheet later on. So from here, you know that is basically the summation of the expression earlier on. Okay. Now what you guys might do is, all right, it's a negative sign, so method of difference. Answer is no, but it's possible. Okay. Now, if I do method of difference, you realize that, okay, I have ln 2 minus ln 3 plus ln 4. I have ln 3 minus ln 4 plus ln 5. Then you realize that I have cancellation like this. It's still possible. The only thing is that, how are you going to get it to the end? Right, because now you have ln 4, and then you have ln 5, ln 6. You notice that this ln 4 is going to stay. So this cancellation is not going to work. Because what you might accidentally do is, oh, I cancel like this, right? It means that every term I do, I'm going to get this, which is not true. Because this first cancellation is just pure coincidence. Right, as you're going to see later on, ln 4, ln 5, you notice that these lns are not going to get wasted. They're all going to be remade. Whereas, you notice that the cancellation on the right will work. All right, so you still could do MOD, just that you need to be very careful on how you're going to do it. All right, so this is why I mean by be open-minded as well. You need to be adaptive. Is when you realize that something is not happening, something that is weird, you need to stop and really think through it. Whether is it MOD? All right, which in this case, you still can use MOD. All right, you notice that the terms on the left is going to remain, whereas the terms on the right, you're going to get so terms on the right, you're going to get ln n, which is going to get cancelled, plus ln n plus 1. And the thing is, you have these parts right here, minus ln 3 plus ln n plus 1. So what's the problem here? All right, now it's still doable. All right, so this goes back to basic techniques. How do you gonna combine this to one single logarithmic function? Answer is possible. All right, you have ln 2 plus ln 3 plus all the way to ln n minus 1, which means that if you recall, ln a plus ln b give you ln ab. Now you have ln 2 times 3 times all the way to n minus 1. We have ln n minus 1 factorial plus ln n plus 1 over 3. If you want, you can simplify this together. Now you have n minus 1 factorial times n plus 1 over 3. So this is the answer, which is also equals to, very nicely, ln n plus 1 factorial over 3n, because we times n over n. All right. Now, so this is the MOD way, which carries great risk if you don't realize that, hey, this right side term is actually going to remain intact. All right. Another way to do it, in fact, is by using this idea here, the property of ln A as ln B. All right. So let me just create a new slide. Okay. So we have the summation of ln R minus ln R plus 1 plus ln R plus 2, which we already found out is, well, go back to basics, summation of ln R minus summation of ln R plus 1 plus summation of ln R plus 2. Of course, from the limits of R equals to 2 to R equals to n minus 1. So I'm going to write down the limits properly. Okay, then you know that, well, from earlier we have ln A plus ln B plus all that is basically ln A times B, all of that. So you know that from here, we can just do it very simply. This is ln n minus 1 factorial. This is ln n factorial. This is ln n plus 1 factorial. Now we just divide them together. No, I'm not missing out anything, right? Oh, I'm missing out some things. Yes, okay. Yeah, so I felt like something was wrong already. Okay, so here's an important thing. I skipped many steps right here. So go back to simplicity. So you need to expand the, already think through what kind of summation it is. This starts from ln 3, ln 4. You're missing the ln 2, so you need to be careful and not do what I almost tried to do. Ln factorial over, forgetting the ln 2, so n factorial over 2. All right, because this is ln n factorial minus ln 2, because I'm missing the ln 2 here. Similarly, for this one, we're missing ln n factor is n plus 1 factorial now. But we are starting from ln 4, missing ln 3 and ln 4. So minus ln 3 minus ln 2. Oh, this, yeah. Then from here, you then can then combine everything. So that's a good thing. So we ln n minus 1 factorial, ln n plus 1 factorial over 2. Here is plus, so we get 2. Ln 2 minus ln 2 is 0, then minus ln 3, so we divide by 3. Then n factorial, n factorial. Then from here, it's actually the same thing, all right? You notice that we get the same answer, n minus 1 factorial, n plus 1 over 3. And then, of course, you can times back the n to get the same answer as just now. So this is also a reason why that's, even though you're in unfamiliar territory, like summation of ln, you can just also just use the basic of law of logarithm, right? It's really just go back to the definition of sigma notation, which is just summation of the different terms. All right, ln A, ln B, ln 1 plus ln, in this case, ln 2 plus ln 3 plus ln 4, then you use the identity of logarithms, then you can get factorial and all that. All right, so this is very basic technique that we can have. So, is there any more examples? I think there are. Okay, so I'm not gonna do this full example because I just want to show you again just annotation. This is a very good question to practice your annotation. Initial size, we know that initial, so t equals to 0. All right, so it's very important because when it comes to differential equations, a lot of people don't know what kind of information they are looking out for. They also don't know like what to look out for. All right, so initial size, initial being t equals to 0. Always annotate. 5 days should be t equals to 5. Size is 20,000 and 5,000. Then t days, m, important is in thousands. So what they like to do is they give the variable and then they tell you that it's bracket in thousands. So you need to take note of that. All right, so this means that we have m equals to 5 and m equals to 20. From there, last part, proportional to 100 square minus m square. And importantly, growth or is it decay or is it something else? Or is it decrease or increase? All right, so rate of growth, again, very subtle information, rate of something. Could be rate of change, could be rate of growth, could be rate of decrease. You need to be careful because if it's growth, we know that it is positive. If it's decrease, it will be negative. So very subtle information, clue, very subtle information, please take note of that. Okay? And from here, you can craft the equation and then solve, right? So that is a general idea here. Big picture, craft a DE, differential equation, solve, right? And then you're going to substitute here and there, right? Because substitute t equals to 15. Here, substitute m equals to 80. That's it. That's the big picture. And this is the general outline. Very simple. 3 steps. Solve, craft DE, solve, substitute. Simple. So when you're doing this question, very simple. I just go by this mantra. Craft DE, solve, substitute. As simple as that. Right. So these functions questions, again, why I put this out because there was a question on how do I solve functions questions of the idea of compound functions, what is the domain, what is the range. I don't think the person's here. So I guess I'll go through it in a separate video. I might do this a content video or I just have an extension to this without you guys around, unless you guys are interested to know. Then I'll go through it. Otherwise, then I'll talk about the ultimate goal of H2 of your H2 math journey. So ideally, right, is along the way you know how to work with the questions, and hopefully you laugh with the questions. All right. Why laugh with the questions? Because you know what's going on. You know how to get the information and you're just having fun. All right. The best, which sounds a bit toxic, is to laugh at the questions like, why are you even testing me? All right. So that is really the pinnacle of being good at H2 math. And of course, being fluent and familiar with the techniques and ideas so you can visualize them and also know whether is there a future down that path, right? For example, that question of the triangle where you try to solve or you try to show that equation, that is the idea of seeing whether there's a future, whether there's a path, all right? Of course, when you create that path, it not be linear, it could be both ways. And knowing how to back out from a dead end and find that right path. Again, that triangle question is a very good example. And taking inspiration from how you get lost. Taking inspiration from either how you got lost or on the process of getting lost or the questions or from the information that you might not have considered. All right, so sometimes the clue is really given down there and it's very subtle. So always experiment by finding different clues and really trying to match it. Okay, so for my future plans, I don't know, these are just some things that I might do. All right, more live demos for each chapter or just recorded demos and go through the specific techniques. And of course, the feedback form, which I think I sent it through the email. I'm gonna get the link right now. And yeah, you guys can also feedback to me what you guys would like to see for future math content or future Inkie content in general. Need not be math, could be like chemistry, could be physics, could be econs. Yeah, that is. Actually, I can just copy the link from here. Yeah, so any feedback will be appreciated. So right now, I'll just move on to the any Q&A. I mean, any questions that you guys want to ask. I think one thing I forgot to put inside is, let's say you're doing topical practices. what you want to do is to not cram or not speed run a certain topic, every topic at one go. So like let's say you're doing sequence and series, you don't do all questions on the sequence and series chapter and then move on to the next one. What you should do is really just do one of each, right? So let's say you have chapter 1, chapter 2, chapter 3, chapter 4, and so on. You want to do one question from here, one question from here, and then one question from here, one question, basically one question from each topic every day. Nothing more, nothing less. So that you know in a way that you can gear yourself towards the exam where you are going to be meeting different topics at different times, and also in a way to also keep your techniques fresh. All right, because if you're so used to only doing or remembering techniques by doing doing it often at one go, then you might come to a point where you may not actually remember it properly. Right. So let's say you try to move on to another topic. By the time you let's say hit the third topic, you forget everything for the first or second chapter already. Yeah. So do that sampling idea lah. Take one question from here, take one question from there. So I hope today's session was useful in terms of knowing how to proceed with your revision or with your approach to H2 math, or at least how you're going to do that question, is really to really seek out that information, right? And really get used to the techniques. Of course, this webinar is basically just a more generic kind of advice, not very specific to any topics. Of course, if you like to have topic specific advice, you guys can either look at the skill sets, which I think I should send the link. I'm still in the midst of updating some of the skill sets, some of the chapters. Let me just get the link of the skill set. Okay. Yeah, so this link I'm gonna send basically covers all the skill sets of almost all pure topics. Actually, all pure topics except for inequalities and functions. And it has also the normal distribution right there as well. So for those in J2, normal distribution questions, normal distribution skill sets are there as well. Yeah.